Welcome back, everybody, to the deep dive. Get ready to have your minds blown because today we're talking about something that sounds like it's straight out of science fiction.
Yeah, it really does, but it's actually based on real cutting-edge research.
That's right. We're talking about AI that can design brand new materials, not just discover materials that already exist, but like create them.
Exactly, from scratch.
So like imagine being able to 3D print, I don't know, a custom designed phone case that's like super strong and lightweight, all thanks to AI.
And that's exactly what we're going to be diving into today.
All right, so tell us what we're looking at. What's the source material for this deep dive?
So the source is a research paper from Microsoft Research about something called MatterGen.
MatterGen. Okay, sounds pretty high tech.
It is. It's an AI model, and it has the potential to completely change how we design materials.
I mean, that's a pretty big deal, right? Because almost everything around us, like, relies on materials with very specific properties.
Absolutely. Everything from our phones and computers to airplanes and solar panels.
Even like the clothes we wear.
You name it.
It all depends on the right materials,
Mm-hmm.
right? And I imagine that finding new materials, things that are lighter, stronger, more efficient, that's got to be key to solving some of the big challenges that we're facing.
Absolutely. Things like climate change or just making better, more sustainable products in general.
Right, okay, so designing new materials, that sounds super complicated to me.
Oh, it definitely is.
Like, aren't we talking about, like, manipulating atoms and molecules here?
Right, exactly.
How does AI even begin to, like, wrap its head around something like that?
Yeah, and for a really long time, scientists have been kind of stuck with these really slow and expensive ways to discover new materials.
Yeah, I can imagine.
Like, imagine mixing different things together in a lab and just hoping for the best.
Trial and error, basically.
Totally. Or even searching through these giant databases that, only show a tiny fraction of what's even possible.
Like finding a needle in a haystack, except the haystack is made of, like, atoms.
Hmm.
So is this MatterGen AI, is it just like a super fast database searcher?
It's actually way more creative than that.
Okay, so it's not just searching, it's actually...
Think of it this way. Imagine an AI that can compose a whole new piece of music instead of just like finding a song from a playlist.
Oh, wow.
That's what MatterGen does. It designs materials from the ground up.
Okay, that is really interesting.
Oh.
But how? Like, how does it do that? Does someone have to, like, program in all the laws of physics and chemistry?
It's actually kind of the beauty of machine learning.
Okay.
So they trained MatterGen on this massive data set of existing materials. And from all that data, it basically learns the rules of what makes a stable structure.
So it's learning from the best.
Exactly.
All the materials that already exist and that actually work?
Yeah.
Okay. But is that even possible? I mean, isn't the number of, like, potential material combinations just mind-bogglingly huge?
It is, and that's why the diffusion process that MatterGen uses is so clever.
Diffusion process, okay.
Yeah, so imagine starting with just like a lump of digital clay, like a totally random jumble of atoms.
Okay.
And then MatterGen gradually refines and sculpts that structure, guided by the training that it's had and the desired properties, until it arrives at something stable and unique.
Okay, so it's not just like randomly throwing atoms together. It's more like a digital sculptor,
Yes.
chipping away until it finds something amazing.
Exactly. And what's really neat is that this process actually mimics how nature itself might discover stable materials.
Really?
Over time, through these gradual changes and evolution, it's like AI-powered evolution, in a way.
So they're basically like speeding up evolution.
Yeah.
Wow, okay. So what happened when they set MatterGen loose? Like, did it actually create anything worthwhile?
The results were honestly really impressive.
Okay, spill the tea. Like, how impressive are we talking?
MatterGen is creating stable, unique materials at a rate that's just blowing past anything we've seen before.
All right, give me some hard numbers here. Like, how much better is this AI compared to what we were doing before?
So the materials MatterGen creates are more than twice as likely to be both novel and stable compared to like any previous attempts. And not only that, the structures it's coming up with, they are 15 times closer to that ideal lowest energy state.
Okay, 15 times. That's a huge improvement.
Huge.
But can it go beyond just creating something stable? Like, can we tell it to make, I don't know, a material that's magnetic and flexible?
And that's where things get even more interesting, because MatterGen is not just like a one-trick pony.
Okay.
You can actually fine-tune it to design materials with very specific sets of properties.
So it's not just like set it and forget it. You can give it a whole wish list of properties.
You got it. And the researchers actually showed this off by having MatterGen tackle a problem that has like real-world implications right now.
Ooh, okay. What problem did they throw at it?
They challenged it to design a new material for permanent magnets.
Okay, magnets. Those are in like everything.
Everything, yeah. From electric motors and wind turbines to like, just the fridge magnets holding up our grocery list.
Yeah, exactly. So what's the big problem with magnets right now?
So a lot of high-performance magnets depend on rare earth elements, which, as we all know, come with all sorts of supply chain issues and environmental concerns.
Right. Not ideal.
No, so they gave MatterGen this two-part challenge.
Lay it on me.
1, design a material with high magnetic density.
Okay, so we need a strong magnet. What was the second part?
The second part was to make sure that it's made from elements that are readily available.
Right, so no rare earth elements this time.
Exactly. So they wanted a magnet that was both powerful and sustainable.
It's like a tall order. So did MatterGen manage to pull it off? Did it find this magnet unicorn?
That's what we'll be diving into when we come back.
Ooh, cliffhanger. Don't go anywhere, folks. We'll be right back with more on MatterGen and the future of materials. All right, welcome back to the deep dive. Before the break, we were talking about MatterGen and this challenge of designing a better magnet.
Yeah, a more sustainable magnet.
Right, without using those tricky rare earth elements. So did it actually work? Did the AI come through?
Yeah, it totally did. The research paper highlights some really impressive results. MatterGen actually came up with several promising candidates, materials that could offer that high magnetic density, but without needing those rare earth elements.
Okay, so that's huge, right?
Yeah.
No more scrambling for rare earths. We can start making more sustainable technology. But if it can already tackle a problem as specific as like magnet design, what else can this AI do?
That's what's got everyone in the material science world so excited. It's not just limited to magnets. MatterGen can actually be targeted to design materials with all kinds of properties. We could be talking lighter and stronger materials for aerospace or biocompatible materials for medical implants.
Fine.
Even self-healing materials for construction. You name it, this AI could potentially design it.
Okay, so now I'm really starting to see why this is such a big deal. But I gotta admit, I'm still a little fuzzy on how this diffusion process actually works. Can you maybe give us a simpler way to understand it?
Okay, have you ever shaken up a snow globe?
Yeah.
And you have to get all the little flakes to settle down in a nice way. Well, imagine MatterGen doing something similar but with atoms. It starts with this totally random arrangement of atoms, like those flakes swirling around in the snow globe. And then it uses what it's learned to kind of gently nudge those atoms into a more stable configuration.
Okay, so it's not like brute force smashing atoms together. It's more like guiding them.
Yeah.
Gently.
Exactly. And just like with that snow globe, sometimes the coolest patterns happen when you just kind of let things settle naturally.
Right. That actually makes a lot more sense. So this is all happening on a computer though, right?
Oh.
It's not like MatterGen is physically building these materials atom by atom.
Right. It's all digital. It's creating blueprints for new materials. And then it's up to, scientists in the lab to take those blueprints and actually synthesize the material.
So it's kind of like a partnership.
Yeah.
AI doing the heavy lifting of the design, and then humans making it real in the lab.
Exactly. But, there are definitely still some challenges to figure out.
Oh, of course. Nothing's ever perfect. So what are the hiccups here?
Well, for one thing, like any AI, MatterGen is only as good as the data it's been trained on.
Oh, that makes sense. So if it's only been trained on existing materials, could that actually limit its creativity? What if the truly groundbreaking materials are something totally different from what we know now?
Yeah, that's a really important point. It's like if you only ever listen to one genre of music, your ability to compose something truly original would be pretty limited.
Right. You got to branch out. You got to broaden your horizons. Right.
Exactly. So researchers are constantly working to expand those data sets, adding in more and more information about existing materials, as well as exploring new ways to generate data.
So it's kind of like better data makes for a better AI, which then leads to the creation of even more data, which then further improves the AI.
Yeah.
It's like this positive feedback loop.
Exactly.
Okay, that makes sense. But even with great data, are there still going to be limitations to what an AI like this can do? I mean, can we really expect it to create any material we can dream up?
Well, there are always going to be constraints. The laws of physics and chemistry still apply.
Right, of course.
You can't just tell MatterGen to, create a material that's both lighter than air and harder than diamond.
Yeah, I guess I would be asking a little much.
Totally.
So what's next for MatterGen? Is it just going to stay in research labs, or can we expect to see real-world applications of this AI?
That is the big question, right? And honestly, the answer depends on a lot of factors.
And like what?
Well, first of all, other research groups are going to have to replicate these findings, make sure this wasn't just like a fluke.
Right, got to make sure it actually works. Classic peer review, gotta love it.
Exactly. And then they're scaling up. The data sets used to train MatterGen, while impressive, are still pretty small compared to the, vastness of what's possible.
So more data, more computing power, basically just like more everything to really push this technology forward.
Exactly. And we'll need to develop even better algorithms and techniques. It's kind of like software development. There's always room for improvement.
Right. Always got to be optimizing. Okay, so that's the technical side of things, but what about the human side? Are scientists and engineers going to have to go back to school to learn how to use this new AI tool?
There will definitely be a learning curve for sure, but I see it more as an evolution of their roles rather than a complete replacement.
Okay, so less time mixing chemicals in a lab and more time.
Yeah.
Well, doing what exactly?
Think of it like the relationship between an architect and their design software. If the software doesn't replace the architect, it empowers them to be more creative and efficient.
Oh, I see what you're saying.
Same goes for MatterGen, It can take care of all that, tedious trial and error of material design, freeing up scientists and engineers to focus on, the big picture stuff.
So setting the goals, interpreting the results, and kind of guiding the AI along the way.
Exactly.
Okay, this is all super fascinating stuff, but we are unfortunately running out of time for this segment of the deep dive. But don't worry, we're not done talking about MatterGen just yet.
When you come back, we'll be wrapping things up with some final thoughts on what MatterGen could mean for the future of, well, pretty much everything.
All right, welcome back to the deep dive. So we've spent this whole episode talking about MatterGen, this AI that can design new materials from scratch. I gotta say, it's pretty mind-blowing. But where do we go from here? What does it all mean? What's the future look like?
Well, that is the question, isn't it? If MatterGen really takes off, I think it could completely reshape the way we think about materials and the things that we make.
So paint me a picture. What kind of world are we talking about here? If we can just design materials for any need.
Imagine a world where discovering a new material isn't this slow, difficult process, where scientists and engineers can, just dream up a new material, decide what properties they want it to have, and then boom, use AI to get a blueprint for how to actually make it.
Okay, I'll admit that does sound pretty awesome.
Yeah.
So what kind of impact could that have on different industries? Give me some examples.
Well, the possibilities are basically endless. In aerospace, we could see much lighter and stronger materials, which would mean more fuel-efficient airplanes.
Right, makes sense.
In medicine, we could design biocompatible materials, so things like implants or drug delivery systems that work better with the human body.
Ooh, that would be amazing.
And in construction, we might even see self-healing materials, which would completely change how we build everything.
Okay, so that's a pretty amazing vision of the future. But with any new technology, especially something this powerful, I imagine there's some concerns as well.
Yeah, for sure. And it's super important to think about those potential downsides, too. I know some people are worried that if AI is designing the materials, then, human material scientists are going to become obsolete.
Right, so robots and lab coats taking over the world. Is that really a realistic concern?
Well, I don't think we need to worry about a robot takeover just yet, but it is very likely that the role of material scientists will change. Instead of spending all their time mixing and testing things in the lab, they might focus on, higher level tasks.
Or what kinds of things?
Well, they might focus on setting the goals for MatterGen, making sure the data it's using is good, and then, interpreting the results that the AI spits out.
So kind of like how architects today use computer-aided design tools,
Right.
but it doesn't replace the architect. It just makes them better at what they do.
Exactly. It's about using AI to make humans better at their jobs, not replacing them entirely.
That makes sense. But even with all those safeguards in place, aren't there always concerns about unintended consequences when you're dealing with powerful new technology?
Oh, absolutely. It's super important to think about how this technology could be misused, right? Imagine if someone used it to, design materials specifically for weapons.
Yeah, okay, that's a scary thought. So how do we make sure that this technology is used for good and not for bad?
Well, I think the most important thing is to keep having these open conversations about, the potential risks and benefits. We need to involve scientists, of course, but also, ethicists and policymakers and the public. Everyone needs to be part of this conversation.
So it's not just about the technology itself, it's about using it responsibly, which is something we talk about a lot on this show.
Exactly. And we need to be thinking about these things now before this technology gets, it's so widespread that it becomes really difficult to control.
Well, I gotta say, this has been an incredible deep dive. We started with this paper about MatterGen, this AI that can design new materials. And I feel like we've ended up talking about the future of pretty much everything.
It's a future with a lot of possibilities, a lot of good ones, but, we got to be careful too.
It certainly is. And I think as we move into this new era of AI-driven material design, it's really up to all of us to make sure we're steering things in the right direction.
Couldn't agree more.
Well, that's all the time we have for today. So to everyone listening, thanks for joining us on the deep dive, and we'll see you next time.
See ya.